Hi folks, this is Mohan Raghavan. Today we are going to see Novice Machine Learning End-to-End project, part 12, root mean square error. In previous videos, we have covered how to see the business requirement by the step, look at the big picture, and we have seen how to get the data and how to split the data and stratify the data. Then we have seen the different insights of data by using the scatter plot with density and color map, and we have seen the correlation under the topic. And after that, we have seen how to prepare the data for the algorithms such as like data cleaning, one-hot encoding, custom transformers, and pipelines. And after that, we have started with a selective model to train it. In that, we have seen the linear regression model with sample data. And today, we are going to see the root mean square error. And after that, we are going to see getting the full data into the linear regression model and see the prediction for that. Let's go into the coding. So before starting, just we will understand what is mean squared error. In general, you can understand like mean squared error is the like performance measurement. We have trained our model and it's going to predict. But however, we need to measure how well it performs. So for that, we need to have some metrics to measure that. In this case, we are going to use the mean squared error. So what is mean squared error? Mean squared error is the average of squared error that is used as the loss function for at least a squared regression. It's the sum overall the data points of the square of the differences between the predicted actual variables divided by the number of data points. In simple words, you can consider like you will be having basically two things. One is like a actual value and another one will be the predicted value in case of training. After predicting the value, we will be comparing both and we will be getting the difference and we will be squaring that and dividing by the n number of items. So why do we need to square here? Because let's say sometime you will be having the prediction more than the actual, or you can be having the prediction less than the actual. In case of difference in minus, then you will be minusing and plus. So let's say if you don't square it, let's say minus value will reduce the plus values. So that's the reason we will square it, then we will sum it. And after summing it to get the actual value, we will be taking the square root for that. So this is about the small introduction about the mean square error. However, I just want to tell you that how to make the content in the notebook, like content like heading and the diagrams here. Just if you double click this one, so you can see the HTML content here. So it should be like H1 and the content header one and paragraph here. Then after that, if you want to insert any images, that location path you need to give. Since I'm using the image from the same path, so I will be using this one. So just if you, and one more thing, this type of cell will be like markdown. So if you go here, you can see the cell type, it should be the markdown. So then only you can write the HTML codes. Now if you just execute this code, you can see the output here. Okay, let's go into the coding. So for computing the mean squared error, we are getting from mean squared error from sklearn metrics. So from sklearn metrics, import mean squared error. Then housing predictions. Now we are going to predict it. Already we know that in previous video, we have trained the linear regression model with the object of lean underscore regression and predict value. So now we are giving the housing underscore prepared, which will have entire data set. Then after linear mean square error will be the mean square error in the bracket. You will be giving the predictions and you will be giving the actual label. So it will have the predictions values. It will be having the actual labels. Then after you will be having the linear mean square error. As we discussed, it will be having the squared error. So we need to take the root for that. So for that, we are using the numpy. In that numpy, the function is square root and we are giving the mean square error. Then the value will be 68911.760 and so on. So this is the root mean square error for our predictions in linear regression model. And one more thing, median housing values ranges between, let's say, so 12 lakhs to 2,65,000 something. So in that case, if you have any predictions, there may be a possibility like it may be plus 68,000 or minus 68,000, which is not satisfying. So this is called underfitting because the prediction, it should have the minimum error. That means that minimum, let's say 3,000, 5,000. In that case, if it is there, then fine. It should be like very minimal. But here it is like more than 50,000. And the actual range is only like 12 lakhs to 2,65,000. Sorry, 1,20,000 to 2,65,000 only. So in that case, 68,000 is the very, very huge one in prediction kind of and prediction error. So that's the reason we will consider this as a underfitting here. Then, however, we have some other models also. So for example, decision tree regression. In this stage, we may not be knowing what is decision tree regression, but consider this is another kind of model to predict the values. So consider in that also we will check it the same way. We will import that module from sklearn.tree. Then after we will be creating the object for the decision tree regressor. As usual, like linear regression, we will be fitting that. That means we will train that with housing prepared and then housing labels. So here we are giving the independent variables, only the inputs, and we are giving the dependent variable housing labels. In both cases, it will be taking and it will be trained. Then housing predictions, then we are just giving the tree underscore regression predict housing prepared. So now we have the total predictions. So it learned from the same data, it is predicting from the same learning. So now we have the predictions. Now in the same way, mean square error, we are giving the housing predictions, but in this case, housing predictions from the decision tree regressor. And after that, housing labels, as usual, we have the data so that we are providing. So then after same way, we will take the square root and we will see the root mean square error. It's coming as a 0. So in both cases, for example, in above case, it is like a underfitting. In this case, you will be getting the error as 0. That means it's accurately just learning and let's say accurately predicting the values. So there will be two cases. One is like it is really very good and it is predicting actual things with the predictions. But another way is like it will be overfitting. Overfitting in the sense it will be more learned and it will be like very much predicting, or let's say very much learned from the data so that it will predict same like that, but it may not be the case with the new data or the test data. So in that case, what do we need to do? So till now we have not touched the test data and we are not going to touch that, but still we need to make sure that this model is well performing with the new data or unseen data. So for that we are going to look for the new concept like cross validation. So what is cross validation and how it will be working in making the data or the model to be very efficient and precise, not like overfitting, not like a underfitting. So in next video we are going to see what is cross validation and how easily we can do within the sklearn. So thanks all, thanks for watching and have a great day.